Hello, everybody. Hi, hola, ciao. Hope you're doing well. So, let's say now you have to understand the difference between a degree and a multiplicity, right? So, this is going to determine the nature of the graph, which I'll shortly discuss. But to start with, you already now know how to define the polynomial function because we have seen, let's say, cubic function. So, the obvious way of writing is ax cube plus bx square plus cx plus d. Now, I want to generalize it. If I have to generalize it to define it in a way that you can accommodate any and every kind of a power in it. So we will write y equals a into x to the power n, where n can be anything, okay? Plus, then now you have to reduce it by 1, just like what is happening with here. It's 3 and then 2. So you will write something like bx to the power n minus 1. And likewise, it will keep going until and unless you reach to a point where you get a constant, let's say d or whatever it is. So x to the power n minus n, this will be 0. And therefore, it will just be a constant. Okay. And interestingly, you can now factorize it. If I were to factorize it and put it out in a generalized form, then it will be y equals a into x minus r1 to the power m1 multiplied by x minus r2 to the power m2. Likewise, you can have a lot of factors and then you go somewhere x minus rn to the power mn. Here, R1, R2, Rn, all these are the roots. But your M1, M2, Mn, these are the multiplicities. So each and every factor will have its own multiplicity. So multiplicity would mean that how many times a specific root is repeating. Whereas degree is, the highest power of the polynomial function that you're looking at. So now I'm going to take one short example and just clarify this particular thing. So you have y equals x to the power 4. Here, x root will be 0. Degree is 4, root is 0, and the value of the root is 0, I mean. And for the multiplicity, you can write it as x minus 0 to the power 4. This is similar to putting it up like this. So what you are getting here is multiplicity being 4. But if I take an example, y equals x square minus 1, I can factorize it further and I can write x plus 1 into x minus 1. So here what I'll get is, I'll get 2 roots. Okay. Because anyway, your power is 2, highest power is 2. So you can expect 2 roots. So here I'll get x equals 1 and minus 1. This can be further written as x minus 1 to the power 1 into x minus of minus 1 to the power 1. So what's happening? In this case, what will happen is your multiplicity is 1, your degree is 2, and you have 2 roots, 1 and minus 1. So this is one interesting thing. Now, why you should be knowing this? So let me just share my screen and I'll just tell you why it's important. Okay. Hey, hello everybody. So here why you should be aware of the multiplicity thing and how is it gonna help you? That's because let us say you have this particular graph where you have a multiplicity 1. So you can expect that this kind will cross sharply, right? But if you have a multiplicity 2 for, let's say y equals x square, this is having a degree also 2. But in this case, your x is 0 and you can express it as x minus 0 whole square. So your multiplicity is 2. In this case, this will touch and bounce just like a parabola. And anyway, it's a quadratic form. But if your multiplicity is 3, then it's a cubic function type of a thing, but it's not necessary because you have to first see what is the function being provided to. So if it's y equals x cube, highest power 3, you can expect a cubic function, fine. But with the multiplicity being 3 here because of the roots, so here what is happening is that it's crossing, but it's flattening here. If I look at the tangent, and if I look at the tangent here, you see there is a difference in the pattern of the nature of slope. here and here. It's flattening near the axis here. And because it's odd, x cube, it's odd. So the tails are also not pointing in the same direction, it's pointing in the opposite direction. But because this is even, y equals x squared, this being even, so here you can see that these things are pointing on the same direction. Yeah. But if multiplicity is 4, for let's say y equals x to the power 4, very simple. So here the tangent, if you draw to this particular point here, you will feel the change from here to here and then here. It's becoming more flattened near the axis. So a tangent has a relation with the slope. So it's becoming more flattened here. If you look at the slope here, it's different. If you look at the slope here, it's different. I hope you understand that when we talk about slope, drawing a tangent to a curved nature of a graph can help you determine that, right? So here, that thing is being clearly understood. It's very flattened near the axis. So higher the multiplicity, you know, you can expect if it's on the even side, like if it's high multiplicity and it's even, kind of a function. So you can expect the nature to be more flattened. And yeah, also that these two ends will be pointing on the same direction. Again, whether a is greater than 1 or a less than 1 to understand if it is going to point up or point down. That is one thing. But if it's odd, just like multiplicity 1 or multiplicity 3, these are the odd ones. So for this particular thing, either it crosses sharply or it crosses, but then it flattens as well. But it doesn't bounce back. Had it been bouncing back, situation would be different. But in even, it's bouncing back. Why bouncing back? Because it's not going here, it's going up. So that's the thing. So thank you so much for watching and stay tuned. We have come to the end of the polynomial functions overall understanding of that. Stay tuned. And I'm going to share the QR code shortly with you for this particular topic. So in the next video, we'll cover that and we come to an end for the polynomial functions. Stay tuned for the last video of polynomial functions. Thank you so much.